Good afternoon, students, and I welcome all of you to the first live session of this MOOCs course on membrane technology. I am sure you are enjoying the course till date, and I know that there is a very good response on assignments also. So let me brief little about this particular course. Already the course is started and you have done so many lectures. So the course actually is having started with an introductory lecture where we where I discussed about what is the how the membrane technology has developed, and then we have gone to know the different types of membrane materials and their properties. So like polymeric and different types of polymeric materials, different types of ceramic membranes, ceramic materials, what is their properties, right? So basically the feedstock to prepare membranes. In the next phase, next slot, we have started studying and discussing about how to prepare a membrane. So that is there was elaborate notes on those, how to prepare membranes, different types of membranes, starting from ceramic membranes. Then we have also, polymeric membranes. Then also we have discussed ceramic membranes. Now, once we have prepared the membranes, the first and foremost important thing is that how do we characterize the membrane? How do you know that it is a membrane? Right, it's a very important thing. Suppose I give you a piece of a paper like this and tell that can you tell me what is whether it is a this particular piece of paper will work as a membrane or not? What should we do? Right. So that means you need to characterize by some means and tell that yes, this can be a membrane. So based on what? Based on nothing but the pore size. Right. So you know that the pore size of the membranes, which we call membranes, right, are far less than the traditional filters, filter papers, cloth filters, and all such things. Okay. Now, in that respect, we have discussed in great detail what are the different types of characterization techniques for the membranes, right? Starting from the characterization of the microfiltration membranes. Then we have discussed about the ultrafiltration membranes and RO membrane and so on and such things. So some of these techniques which are very, very lab scale techniques, okay, or which you can develop at the lab scale, like let us say the flux technique, where you measure the flux of a pure water. You can also measure the flux of gas, okay, and find out the pore size. Now there is bubble point techniques, there is thermoporometry, porometry, there is mercury porosimetry, then there is SEM, there is STEM, there is AFM, right? So the list is endless, and we have in detail we are studying actually what are the different types of characterization techniques. Now once that part is over, then we'll slowly deal with into the transport mechanism, that on what principle actually the membrane separation happens. So this is actually very important. This has a lot to do with the thermodynamic principles, right? So I have prepared the lecture in such a way the persons or the students who have not read thermodynamics can also understand that, right? So a very important part of the course is the transport mechanism. Then once that part is over, we will slowly proceed towards one by one different types of membrane processes. So what will start is nothing but microfiltration, the base membrane, and we club nanofiltration with that also, right? Then we proceed to ultrafiltration, then we will go for the RO, right? And like that, I think, sorry, RO is the first, then we go for RO and nanofiltration. They complement each other actually. Then micro, then ultra, then we go like this. Then we will also, in lieu of the course, you will also see that there are many other hybrid techniques which we will be dealing with. So hybrid techniques in the sense that more than one unit processes are clubbed together to achieve a desired separation, right? So it can be for the gas separation, it can be for the liquid separation. As you know that membrane technology is used for various types of applications, for enrichment of liquid and gas stream, then for separation processes, purification processes, and the list goes on. Okay. Desalination, potable water. We'll also discuss dialysis and then what is hemodialysis, the medical application, right, of the how the patients actually carried out the hemodialysis. Okay, and then we'll also learn some other techniques like pervaporation, which is the name comes from permeate evaporation. So it is a thermally driven process, membrane process, where thermal energy is also used. Then we'll also learn about other techniques. Okay, like let us say there is a 50-50 azeotrope. How do you break it? So the traditional way is to use the azeotropic distillation, right? So here, with the advent of the membrane technology, what we have done, or what we'll see or discuss is basically you will see that the membrane is used to break the azeotrope, right? Let us say A plus B mixture. So membrane will break the A plus B into A rich and B rich. Then the A rich stream and the B rich stream will simultaneously go to two separate distillation columns to further purify them. So this is one of the latest technological intervention with the help of membrane that is possible. Now, I think this is all about the course, how the course will proceed or is proceeding. I'm sure you are attending classes, lectures, and also doing the assignments. In case you have queries, you please feel free to write to me. We are replying. The TAs are there. There are 3 teaching assistants who are helping me in conducting this course. So they are answering your queries. I am also answering. So I'll be very happy to answer any specific query if you have. So with this, I remain, and next time live session we'll be discussing. I'll discuss with you the question patterns for the final examination. So thank you very much. I'll stay tuned for some time to see whether people are joining, and I'll be happy to take up questions or queries, whatever if you have. Thank you. No, I cannot share the PPTs for other reasons. So what easily others do is that you can take a snapshot and of the video of that particular slide and then go through that. So I'm not able to share the PPTs with you. Okay, so one Sushant is asking how to differentiate whether the membrane which I am preparing is an microfiltration or ultrafiltration or nanofiltration before characterizing. Now, before characterizing, you cannot understand whether it is what type of membrane. I'm sorry about that, because you need to characterize. So any such membrane which you are preparing will have some separation characteristics or features by virtue of the presence of pores. Now, but what type of pores, then what are the size of pores, that tells me whether it is microfiltration, ultrafiltration or nanofiltration. Got it? So we need to characterize at least by the water flux method, the minimum small, the small one, where you need a small membrane cell, and you need to fill the cell with the sorry, fix the membrane over that, and then we have you can put water over it and see how much water is coming at different intervals of time with different pressures. Okay, applied pressures, that will give me some flux data. From that you can fit the equations and find out what is the pore size d. Right now, without doing anything you cannot understand, so that is very much clear. think we can close it now because there are no more students, no more queries. So I'll join for the next one at 4:10, 4:15 like that.